All right, now that we've determined that a function is one-to-one, now we can find its inverse. And that's what this looks like right here. This is our inverse. So it doesn't mean reciprocal of a function, it means inverse, it means opposite. And the way we find the opposite is just by switching the x's and the y's. So we take our x and our y, and we switch it. And there we go. There's our inverse. And now you might be able to see why we need it to be one-to-one. In order for this to be a function, we can't have repeating x values. So if we're going to switch them, our y's are becoming the x's, then we can't have repeating y's to start with. Because when we switch them, we don't want repeating x's. That's it. So this is one-to-one. So when we switch them to create the inverse, we are not getting repeated x's in our inverse, which means it is a function still, one-to-one function. All right. So to find the inverse of equations, to turn those functions, so that's a function, function, one-to-one, 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 one-to-one. All right. We can now switch them and then solve for the y. Because remember, the y is what we're replacing to create a function. And there it is. So this is our inverse. So all we have to do now is replace the y with the function notation of an inverse and rewrite it. And that's all you have to do to create an inverse. Let's try it again. So we switch them. That would now be x, and that would be y. And then we have to solve for the y, which means adding 3 to isolate the cube so that we can cube root it. And then put it in its inverse function notation. And there we go. Try one. Try this one. Hit pause, give it a shot. And there's our inverse. You could have also distributed the negative and even separated it and had negative 1/4 x minus 5/4. That would also work as well. All right, I was going to have you try this one, but this one's kind of special. So we're going to do it together. So again, to find the inverse, we just switch the x and the y, square both sides to get rid of the square root, and then solve. And then write our inverse. If you're very observant, you may have noticed all this stuff over here. There is a domain that's given to this. So what's happening is the domain and the range are actually switching. So this would now become our range, and you replace the x with a y. And this would become the domain. You replace the y with an x. So our domain on this function is x is greater than or equal to 0. And our range on this function is y is greater than or equal to 2. And to show you what's happening, let's look at it graphically. Okay? So the first thing we're going to do is graph that function y is equal to the square root of x plus 2. So if you remember our translations, we start at minus 2, and then right there is our quadratic. So if we plug in 0, we get square root of 2. I don't like that. But if we plug in 2, we get 4. So that gives us right here, and it'll give us a nice rough graph right there. Okay. Now we're going to do the other one in green. And this is a quadratic, and we're at minus 2. And then it's going to be up 1 over 1. And we get our quadratic. Right, like that. Because also if we plug in 2, we get 4. Where is it? We plug in 2, we get 4 minus 2 is 2. Same point right there. Okay, so, but our thing is we have a domain here that says x has to be greater than 0. There's our x. We're not getting this value over here at all. So if you look at them, they are a mirror image. They're opposites of each other. There's actually a line going through them. Just like that. That's the y equals x line. And if you can see, they're a mirror image of each other. They are opposites of each other. This value right here is negative 2, comma 0. And this value right here is 0, comma negative 2. You see how they're switched? Even this little point right here is negative 1, 1. And so we should have a point at 1, negative 1, right there. See? X's and Y's are being switched. Even at 2, 2, well, you switch it, you get 2, 2. But you see, it's a mirror image across here, across this y equals x line. And that's why we had a domain and range here, is because we don't get any, we only get real number outputs when x is greater than negative 2. And so that's this one right here. Well, if we're only getting this shape here, then this bottom quadratic also has to be cut, right? Because they're inverses of each other. We want this one to also be 1 to 1 because that one's 1 to 1. So we're cutting the graph right here. X is greater than or equal to 0 to get our mirror image. So if you have a domain or range given with the problem, you want to have that domain or range at the end. Okay? Thank you.